Hey everyone. For this hands-on activity part, I thought I'd do a quick little video to kind of show you some things of what I'm going to be accomplishing with this. So the kind of title of this is Getting Information from a GPS. So far we've been learning about GPS, how does it work, how does it gather the information from the satellites, and turns out it fixes it into a location. This part here is how we get that information from that GPS satellite receiver into our devices, whether it is a display in the cab or for instances, we can even put it in a computer for that matter, or into our smart device. So that is kind of what the whole goal is of this little mini lecture. So to kind of begin with, kind of a then and now. What we've seen in the past, and we can kind of see how the evolution of technology has been great for us, is that we can see back in the day, when if we wanted to do crop scouting with GPS, that was a system that you had to wear. It was a backpack system. You could see the GPS sitting on the top, connected into a device that the guy has in his hands. And inside that backpack is all the cables, even the battery to run that system. Quite a bit of weight there. It wasn't the most best system to have. It was kind of hard on your back if you did it for long periods of time, day on end. Now you look at what we have today. Smart devices like an iPad or even my Android device, smartphone, can take that out. I have all the software on there. It has a GPS built into it. Another way of looking at it is looking at some basic GPSs from back in the day. On the left there, you see that is a Garmin E-Trek system. That was big back in the day. Kind of see the black and white screen with very basic graphics. And then now on the right hand side, most people have a smart device. On that smart device, we have everything in there from maps and all the other things that go with it. So quite a big contrast to what has happened over the years in terms of GPS and how we see it being used in agriculture. So to begin with, we're going to kind of take a look at some smart apps, the smart device things, kind of a little bit of understanding how does that GPS and looking at some of the basic things. So when you're looking at a smart app, there's numerous ones out there. In fact, if I um, switch over here to the Apple iPad store, this was one software I found, smart app, GPS navigation and heading. In fact, if I go back a page, there is, you can see here's all the different apps. In fact, they even have their own navigation section in there just to show you what it is. For the Android folks, same thing there. If you go into the Google Play Store, you type in GPS, you get numerous results of software that is out there. The one I'm going to focus in on today, because I'm an Android person, also have some iPads, but I do a lot in the Android, is this one called GPS Test. So, smart apps. What are some things you should look for? Number one is make sure that the app can give you your location, your coordinates, that being your latitude and longitude. If you go out on Blackboard, there's a nice little web link out there that kind of goes into greater detail of what is a latitude, what is a longitude, and what does it mean. Please read that and understand that before you go any further through these things. Another one is look at the satellites. Be able to see what satellites are up in the sky at the current time, as well as not only seeing the satellites, but what is their signal strength, what is my accuracy going to be from them. Another thing to look for is that if you are driving or if you're moving, it's going to be able to give you a speed. It's also going to give you current date, current time, and some other ones, and this is where you see some extras, is being able to store a waypoint, to drop a pin in the map saying store this location so I come back to it later, as well as navigating, being able to navigate from point A to point B. If those have it, great. Sometimes they may be a paid device. So like I said, I'm going to be using the GPS Test app that you can find on the Google Play Store. So when you download the app, it's free. There is a paid version that gives you some more access, like the navigation and the waypoints. But when you get into it, and we'll see this a little bit later on in the precision ag side of things, this screen right here kind of shows us to begin with. Here's the GPS satellites. Here's the ones that we're connecting to. Here's the information I'm seeing. So as we can see here at the top, it's doing that calculation. It's telling me my accuracy right now is about 15 feet plus or minus. So what I did, I just took this phone, I went outside here a little bit ago and just took some screenshots. The main part that we see is here's the different satellites I'm picking up. Now, if you were to count off these charts, you're going to notice there's 12. Typical GPS receiver is what we would call a 12-channel receiver, which means it could process 12 satellites at the most at any given time. We see some newer receivers that can do more than that, but a typical basic GPS receiver is typically going to be rated in channels, and we're going to see when it says 12 channels, it means I can pick up 12 receivers at the most. So right now it even tells us that, hey, there's 18 satellites in view, I'm utilizing 15 of them, and here they are. Now, what the color coordination means here is how good of a signal am I getting from these satellites. So green is being good, yellow is fairly good, and red, the orange, as you can kind of see down here in the bar chart, not so good. The other thing to note is that these satellites in the U.S. system are going to be numbered. So if we're looking at satellite 29, satellite 38, you're going to see on the next slide where this kind of comes into play. So on this slide here, what we're looking at is we're looking at how the satellites are arranged in the sky. And the way you read this, kind of what I would call the bullseye or the dartboard is another example for this, is you with the receiver are standing dead center in the center. And as we move further out, we're going further out across the sky. So satellite 16, I'm standing here, the satellite, the further out I go, the further closer I'm getting to the horizon. So satellite 16 is darn near above me. And as I get further out, as I'm heading from 16 out to 26 to 74, 16 is fairly high up in the sky. 26 is about 45 degrees out. So imagine at a 45 degree angle from where you're at is where satellite 26 is. 74 then is right on the horizon. Now the other thing that we're going to look at here is the numbers going across the outside edge. So as you see, we have a 0, 15, 30, 45. That's what we call the azimuth. And the azimuth is our direction or our heading. So the way we always read it, 0 or 360 degrees. Most times we're going to call it 0. 0 would be due north. 90 degrees then would be due east. 180 degrees would be due south. 270 degrees is due west. So once again, since wish I would have had the 0 pointing straight north, but I couldn't get my phone to do that the way I wanted it to. But as we kind of read this is, as we're looking, standing here in the center, if we're kind of looking to the northeast at 60 degrees azimuth, that is where we're going to see satellite 16. Almost above us, a little bit heading towards the horizon. Another good example, satellite 85. It is strictly due east of my location, and it is getting fairly close to horizon. You notice that the satellites that were further out, typically these are the ones we're not getting a good signal because they are on the horizon. They're not up in in a better viewing position for us to see. So azimuth is one of those key things when we talk about someone says head 90 degrees 90 degrees azimuth. That means we're going to head due east. Make sense? If not, you may want to study this a little bit more before you move on. So the next screen here that they have in this app is kind of a nice one because it shows me my latitude and my longitude. So it says I'm at 42 degrees, 31 minutes, 16.592 seconds north, and this would be north of the equator. And that it would be my latitude. My longitude is 93 degrees, 17 minutes, 01.144 seconds west of Greenwich Mean Time, which is in England. And you kind of see that by the line here on the map. So I'm in northwest quadrant of that. And right now it says, yes, where I'm at, I'm in dark hours. You kind of see where the sunlight sets. So it's kind of a nice little handy screen to have. This one here is kind of similar to that azimuth, as if I was actually moving, and I was a little bit, it would tell me what my heading is. So once again, my heading is at 26 degrees. So I was kind of heading mostly north, a little bit northeast. And this screen here is kind of a nice one because it's kind of giving me some, like we have mentioned earlier, GPS systems have very accurate clocks. And so it's showing here's what my GPS time is, and that would be at Greenwich time. And it does a calculation. It says, yep, we're 6 hours behind that. So this was at 9:17 at night. And the nice thing is it also gives me when sunrise and sunset is. So it's kind of a handy little part to the application that I've kind of enjoyed. And the last one here, just basically if I was actually moving, it would show me what my speed is. It would also show what my heading or my azimuth is. The nice part here is it also gives me my altitude, and this is in mean sea level, MSL. So right now, where I was standing in my backyard, I was at 1,113 feet above sea level. So handy little app. Tons of other apps out there that kind of do something similar. Always kind of fun to mess around with and play with. Now, how does this carry over into precision ag? Well, when I kind of showed you this earlier in the video lessons, here was a screenshot from my GPS a couple years ago, and show things to note on here. It's actually showing me here's my latitude, here's my longitude, what my elevation is, how many satellites. So I'm currently seeing 15 satellites. My differential is on. I was sitting still at the moment, so it's not recording any speed, and other things that are going on. What to note, and you could typically see this in most precision ag display systems. If you're having GPS issues, or you think you are, there's ways you can go in and double check things. So what you see highlighted down at the bottom, this is on Ag Leader system. They have a couple options, one that's called satellite plot and another one that's called view messages. So if you click on the satellite plot button, this is what pops up. So once again, kind of looks familiar, right? So once again, I'm kind of seeing that dartboard, and I'm getting to see the satellites that are there. Here we can see satellite 2 is pretty much right overhead. They're also giving us information that's going with each satellite, so we could see even the azimuth. So right now it says satellite 2 is at 351 degrees azimuth, so it's almost due north. And once again, we see the ones that are further out on the edge are the ones that we're not going to be getting a very good signal on, so we're not going to be doing much information with it. The other nice thing too is it also gives me how many satellites are in view, how many it's actually tracking, and once again, here's where my HDOP and my PDOPs are coming into play. So now if we went back, we can hit that little back button in the upper left hand corner. If we go back to the previous screen, and then if I clicked on view messages, what that does, and this is kind of where it all comes together. View messages is where I'm going to see, and we can kind of see a screenshot here. We get what's called a NEMA string. And so the string, this is the string of information. The GPS has calculated my position, and now it's pumping that information into whatever device I have connected into it. What you're seeing here is it was connected into a computer, so I'm getting the information off the computer through an app. Inside this message, this is a universal language. So what we're seeing in here is a little bit of latitude, a little bit of longitude, a lot of other pertinent information, maybe what my heading is, what my speed is, information like that, which satellite it's coming from, all that information is coming in. It's in a universal format. And that kind of comes in key later on. So here's a question for you. Can I hook an Ag Leader GPS into a John Deere Green Star system? And you can kind of think about that. Either come up, it's a yes or no answer. So think about it. What do you think? Well, the answer is, I kind of gave it away in the previous screen, is yes, it is. Yes, it can. Any precision ag system, for that matter, can use any type of style or GPS 98% of the time. Pretty much it's going to be 100%, but you never know. There is some systems out there where it's an old GPS from days gone by and someone wants to utilize it. May not work. So how does that work? Well, to get an Ag Leader GPS to feed into a John Deere system, you just need to know the right tape. Just need to have the right cable. So once again, it's utilizing that NEMA string. So John Deere is going to read a NEMA string. Ag Leader is going to read a NEMA string. Case, Trimble, Raven, you name the manufacturer, they can read the NEMA string. So most GPS receivers, once again 98% of them, Wish I could say 100%. Most of the ones that we deal with these days will do this. So we could say this with 100% certainty what you're going to see. Those receivers send out that NEMA string. So NEMA is actually, it's an acronym for National Marine Electronics Association. And as we said earlier, it's a universal language. Not going to go into further details for the matter of this unit. We get into that in more advanced classes in the Precision Ag program. So, a couple other things when it comes to the GPS receivers. And this is, I put this in here because I've seen some situations, issues in the past. What to think about. If you have a GPS receiver, what should you think? So, the key thing is, where do you mount that on a piece of machinery? Some things to keep in mind. Number one, try and put it into the center of the machinery if possible. You don't have to. If you think about some of the older combines where the cab is off to one side, you can mount it on the cab, not a problem. If it's not in the center, it's not the end of the world. With a lot of systems now, you can actually go into the system and say offset it. So if it's not in the center, you could say, hey, it's 36 inches to the left of center. So it's not a problem. But if you have the choice and the option is there, try and put it in the center of the machine if possible. Another one, put it on top of the machinery. Put it on top of the piece of equipment. That's going to give you the best accessibility to all the satellites out there. If you take a look at that sprayer there in the bottom right-hand corner, that satellite is on top. It's on the highest part of that machine. It's going to give us the best view of the sky. Now, could he mount it on the hood of that thing up in front? Yeah, he could. And you're going to get fairly decent signals. However, if you had a satellite that was maybe towards the back of that machine, getting towards the horizon, getting closer to the horizon, then it's not going to be able to pick up that signal as much. So having it on top of the machine is going to give us that optimum accessibility. Another thing too is try and mount it level, not mount it on an angled or a sloped piece, because once again it's going to give us that optimal signal reception. So once again, if I took that GPS receiver and I mounted it down on that hood, that hood is sloped a little bit towards the front. And even if it was sitting up higher up on a sloped level, the GPS receiver is looking up and out. So if there's anything right on the edge of that receiver or below that receiver, it's not going to be able, the antennas inside of it will not pick it up. So try and mount it, always once again, mount it level. Some other things. This was an interesting one I had years ago. Make sure that the cables that come with it are capable of reaching the controller where they need to plug in. I had a producer many years ago that mounted a GPS on the back of his combine, on the back of the grain tank extension. Thought that would be a great place for it. A little bit out of the way, easy to get to if I need to mess with it. I don't have to climb into the grain tank, to the front of the grain tank, or up on the cab. It's there. The problem is he went to all the trouble of mounting it back there, and then when he went to run the cables, he ended up being about 6 feet too short. Cables couldn't reach the destination that they needed to go to. So you can accomplish that by getting a longer cable or buying an extension cable, or you're going to have to move it closer. The other thing is make sure that the dome is facing up. I had this several years ago. Producer had called and says, my GPS is not working. Technician went out there, took a look, and tried stepping through over the phone ahead of time. And yeah, the GPS is just not picking up any satellites. Everything seems to be fine. Got out there and found out that the producer mounted the GPS controller, the GPS receiver, on the bottom side of his mounting bracket, because on the top side he was afraid he was going to hit trees and branches with it on top of the tractor. So he thought, I'm going to put it on the bottom side and protect it. The problem is it was facing down. So it's looking down towards the tractor for GPS satellites that are obviously not going to be there. Something else to think about is we have some machinery that does cause a lot of vibrations. Think about a combine with all the thousands and thousands of moving parts. Vibrations sometimes create that electronic noise that we've learned about. So try and mount that GPS receiver in a place where vibrations are a minimum. Nice thing is this day and age, because of the creature comforts that we have to have, a lot of the cabs, a lot of the systems we have are on shock. Those cabs are mounted on are shock mounted, rubber grommets and stuff where they're mounted to the cab to give us that nice, wonderful, smooth ride. Excellent place to put a GPS receiver as well. As you can see there in the picture, it's mounted on the cab. Vibrations, if there was a lot of vibrations coming from that sprayer, it would be minimized by having it on that cab. The last little part here is connections. As we said earlier, pretty much any GPS receiver can connect in any type of system, just have to have the right connections. So if we're going to connect it to something specific, we just need to make sure that we have the right cable. A lot of the basic GPS systems out there utilize, you can kind of see the picture there on the right, it's what's called a DB9 connection. It's a standard computer connection from days gone by, and the 9 stands for, basically, if you count in there, there's 9 little pins, 9 little sockets where they connect together. So it's a 9-pin connection. Fairly standard. A lot of them use, basically, there's only 3 main pins in that GPS cable that are actually being used. But you want to make sure you get the right cable. Now, I said earlier, we can also connect we could take an Ag Leader GPS or a John Deere Starfire receiver. We can connect it to a computer. Numerous ways that can be done. Typically, we're going to go through that serial connection, that DB9 that I talked about. Fairly common connection that you would see on older computers. That all kind of went away when this little thing called USB came out. USB, Universal Serial Bus. Kind of a newer, faster version of that serial, that DB9. You can buy a USB to DB9 converter, and it works perfectly great. There are some other GPS receivers out there that use Bluetooth, so you don't even have to connect wires. You can just use a electronic wireless connection like Bluetooth. Works perfectly great. Main thing to think about if you're going to connect to a computer, sometimes GPS receivers need an external power requirement. If it's coming from a specific component or a controller, it's wired into there. Computer typically won't provide that, so sometimes you may have to do some external power requirements to make sure that that GPS is connected. Now, something else to think about. A lot of agriculture equipment has ground radar. And if you look at a lot of precision ag systems, they actually have a connection there for a ground radar. Question becomes, why do we need to have that? Well, the nice thing is it's a great backup in case we ever lose a GPS signal. If you have a ground radar hooked up, that radar is producing speed results. Our system is going to pick up those speed results. So if we lose our GPS, it's going to go to that ground radar and say, am I still moving? Yes, we still have speed. I'm still working. Other systems, if they don't have a ground radar and we lose GPS, they think, well, the system is dead, nothing going on. I'm not going to record any information. So if I had a combine, I'm not going to be recording my yield information, and that's all valuable stuff. So a lot of times, having that backup in case the signal is lost is a good thing. So that's the basics on GPS receivers and how we get those connected up to the device, how the device reads it. So here's what your assignment is going forward. What I want you to do, take out a smart device. Pretty sure you have one. Doesn't matter, Android, Apple, what it is. Go out, look on their stores, find a GPS app, download it, take a look at it, go through it, take a look at the features, see what's good, what's bad, and then we'll have a discussion forum posted here on the Blackboard unit. Write a review. And then go through, take a look at others that are in the class, take a look at what they reviewed, and comment on at least 2 of those reviews. What you think about that. Once again, be very professional. Positive comments, no derogatory comments would be greatly appreciated. So that's the first assignment. The second assignment is reach out to a local dealer or reach out to a local farmer who is utilizing GPS, and just go out there and schedule a time and take a look at the GPS systems that are being used. If it's a farmer, where are they being used? Where are they being used? What system is being used? If it's a local dealer, what systems are they selling? Once again, take a look at those. Take a look at the features of those different GPS systems. Also take a look at how they're connected. How does the system read it? So if you're at a local farmer, if you're looking at working with a local dealer, get on the display system and realize and take a look at how can you look at the GPS settings. How does it all make sense? How can I read in the satellite signals and all that? So, and once again, come up with good, bad, what's good with it, what's bad with it. And for this one, I want you to do a video anywhere video reflection. Explain what you did, what you learned from it, and once again, go through the features, what was good and bad, and kind of reflect on that as we start moving forward into future units where this GPS is going to become a very vital part of what we see. Good luck.